All right, what is up, everyone? Hello, and welcome back to Nick Does Algos. In this lesson, we'll be covering the Hackerrank easy rated algorithm, Happy Ladybugs. Gotta admit, this one's a little bit tougher. I'm not quite sure why it is rated as an easy. I think it should be medium, but nevertheless, we'll walk through it, break down the logic, and get to work. So in this problem, we are presented with an array. And here you can see that you have multiple letters presented in the array. Each character inside this array, each item in this list, represents a color of a ladybug. And the criteria here indicate that if a ladybug is directly next to another ladybug of the same color, they are characterized as a happy ladybug. And with these underscores mean that you can replace that underscore with any other character in the array. So here we've got this underscore here. You would want to move this R from the end of the array over here. So you would have two R's next to each other and make those ladybugs happy. That's really it as far as the criteria go. At the end of the day, what you are trying to return is a yes or a no, and that would indicate whether it is possible to take the array and make all the ladybugs happy, or if it's not possible to do so. So in this example, it is possible. We would first move this R over here, and then that underscore would move to the end, and then you would next take this B and replace it with this underscore, and you'd have two underscores at the end, and all the other positions would be pairs of ladybugs. So that is it, really. Let's go ahead and head over to Hackerrank and start to get to work on this problem. So we will start with this example. The inputs are all strings in this scenario, and here we've got a string that's very similar to the one we just worked with, but the order is a bit more jumbled. And basically, without going through a ton of examples, you will come to realize that as long as you have, let's just take some notes up here before we start to work on the code. But yeah, as you work through the examples, you'll start to notice that as long as you have one underscore, if you have at least one underscore, you can make the ladybugs happy. And that's really just because of how it works. As long as you have one underscore, you can keep moving the ladybugs around the array to make them happy. But that's only if something else is true. That's only true if you have at least two of each kind of ladybug. As long as you have at least two of each ladybug. And what does that mean? If you only had one Y ladybug, you could never make it happy. You could never put it next to another Y ladybug. Therefore, you would never be able to make a full array of happy ladybugs. I think that's it as far as the specific criteria go. Obviously, you would want a string of a certain length. You wouldn't just want a string of one underscore. You wouldn't just want a string of one character, but that's really taken care of in our conditions. So let's head into the method itself, the algorithm itself, and start to get to work. So first things first, we're actually going to check to see if we have more than one of each type of ladybug, and we're going to do that using Python's counter function. So up here, we from collections import counter, and then we will initialize a variable and set that equal to counter of b. So let's just go ahead and print that. If you're not familiar with how counter works, this will give you a look at what's going on. I was actually already there. That's funny. Okay, so this is what counter does. It takes your string, it builds an array, and for each character in our string, it counts how many we have. So first you can see that we've got two R's, two B's, two Y's, and one underscore. So great. That meets both of our criteria, right? It's got an underscore and it's got at least 2 of each type of ladybug. But let's first work with our counter and indicate if this is possible or not. And when would we indicate that this is not possible? We would say that if any item in our dictionary appears less than twice, if anything's equal to 1, you would return no. So to write that, we can write for I, j in bugs dot items. Items is a method. We will, if I is not equal to underscore, no, don't type underscore, you can type the character, and j is equal to 1, return no. So what does this mean? If any color only occurs once, return no. Just briefly, I would like to go ahead and print the print what bugs.items is. So we'll do that here, bugs.items, just to show you what we're working with. So it just manipulates our dictionary a little bit. It goes through the items in our dictionary and creates 2 variables essentially. R would be our I in our loop, and J would be 2 in our loop. So it's really just taking those 2 variables and making them workable. So if I is not equal to underscore, meaning it's a character, meaning it's an R or a B or a Y or anything other than this underscore here, we check to see the value of that, and if it's equal to 1, we will go ahead and return no. I'm sorry, I need to change this formatting, just like that. We'll return no. Okay, so that is the whole point of that loop. We will then evaluate our other circumstances. And what's the other thing I said? I said if we have at least 1 underscore, you can make the ladybugs happy. So very simply, you can say if bugs underscore is greater than 0, return yes. And that would be it, right? For the most part. That takes care of our scenarios in which we have an underscore. In this scenario, you can have an underscore and still return no because you have not enough characters to create pairs. In this scenario, you've made it past this, and as long as you have at least 2 of every kind of ladybug, you will get to this part of the function, and you will be able to return yes, as long as you've got at least 1 underscore. Okay, but there is an else to this. And what would the else be? Well, there's one condition that exists in which we can get a yes without an underscore. And that is the condition that our B, let's just add another line of comment here. That is if B is already good to go, meaning you've got a pair, a pair, a pair, and that all the ladybugs are already happy. But it's not just that, right? You can have some other variations of this. You could have, let's say, 3 R's back to back and then 2 B's, and that would be it. You could throw in underscores. Those don't really matter. You could throw in more odd numbers of ladybugs. It doesn't really matter. This is really what we're trying to check. We need to somehow check our string, our B string, to see if all the ladybugs are already happy. And to do that, we need a couple of things. First, we'll initialize a pair variable and set it equal to 0. And this isn't quite going to keep track of our pairs. It's going to keep track of whether or not the number and the number next to it do make a pair. Not the total number of pairs, just whether they do make a pair or not. So there we go. We have our pair variable initialized. From there, we will do a loop, and we will loop through our B string using a range loop. So we can write for I in range. Where we start, we would just start at 0, and we would go to the end of the string. Let's subtract 1 there, and you'll see why that is in a second. And our first condition, we'll try to see if the character and the character next to it make a pair, right? That's what's important. If b of I equals b of I plus 1, we'll pair plus equals 1. Our pair counter will increase by 1. So let's briefly run through an example here. Let's do RRBBYY. Oh, that's exactly what I had above it. Okay, so let's go through our first I here. Our I is equal to R. We'll check the character right next to it. Is that an R? Yes. Our pair counter will go up by 1, and our pair will now be equal to 1. We'll store that number there. And then the next letter is a B, right? But we'll be evaluating this R versus this B. Do the R and the B make a pair? No, they don't. But that doesn't mean we want to exit our loop and return anything. We don't want to say that this is this does not make all the ladybugs happy yet. We just want to set our pair back down to 0 and then evaluate B and the letter next to B. If B and the letter next to B are a pair, well, our pair counter will go up. And if B and the letter next to B are not a pair, then we will exit our loop, or no, we will just return no. Because we know that we have found a scenario in which B and the letter next to it are not a pair, meaning that the ladybugs are not happy and there is no underscore, so they cannot be made happy. So we can do that using an elif. Elif, what is the scenario here? If pair is greater than 0, pair will be set back equal to 0. And that's why I did the 2 R's first, because when we did our 2 R's, our pair counter went up to 1. And then we got to this B, and we said, we don't want to say, or sorry, when we evaluated our first R, our pair counter went up. When we evaluate the second R, we don't want to return anything. We don't want to return yes or no quite yet, because it just means that we are going to evaluate the next character to see if that character has a pair or not. And we know it's going to be a different character because this statement here failed. Because we saw that B of I and B of I plus 1 are not equal, we go here and just say that pair is equal to 0. But what happens next? Well, we evaluate B and the number next to B. This will fail, right? We will not meet this if condition. And our pair has gone back to 0 because when we evaluated these two together, we met this condition. Pair was greater than 0. So we set pair back to 0. We move on to evaluate B and Y. We fail this first condition. It is not true. We wind up failing the second condition as well because pair is not greater than 0 at this point. Pair is equal to 0. So we can satisfy that condition by just saying else return no. Because that means that B and Y are not a pair, and therefore the ladybugs cannot be made happy. But we haven't returned yes yet, right? What if we run into the scenario where we get a pair, and then we get a pair, and then we get a pair? Well, we want to return yes. But how would we get there? We would get there by finishing this whole loop and never returning no. So we would make it through that whole loop. And if we make it through that whole loop without returning no, we would go down here and return yes. And that's it. That should satisfy all of the conditions. And in the end, return us the correct string of yes or no. So I'm going to, the indentation here can be kind of funky, and I know I've already got it correct in my VS Code, so I'm just going to copy and paste the indentation and code from VS Code and paste that. It should all be identical to what we just wrote, and if not, it's just a syntax error or something along those lines. But more or less, let's go ahead and hit return, or sorry, hit run code. We pass both of our sample test cases, and let's run it against all of our test cases, and there you go. We pass all of them. So I've got to, before I wrap up, I've got to shout out Ashwin over at Hackerrank. This is his solution. I could not come up with a better solution than this. This solution is really awesome, so thank you, Ashwin. I just really wanted to take the opportunity to dive a little bit deeper into the logic than Ashwin had. So hopefully this helps. Hopefully it makes sense. And if it did, if anything, if you're having trouble with anything, please comment what you're having trouble with down below. If you enjoyed this video, if it helped you out, please go ahead and hit the like button. And we push out new algorithm videos just about every day. So if you're currently working on algorithms, if that's where you're at in your career, prepping for interviews or anything, go ahead and hit subscribe. I'm sure we'll be able to help you out again at some point. Thanks so much, and we'll see you in the next one.